This is the ROS Developers Podcast, episode 38.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo Tellez from The Construct, and today I would like to dedicate the podcast to all of you ROS developers that are installing ROS in your computer, but you don't have an Ubuntu machine. Yeah, I'm sorry for you. I'm sorry. I know that there are versions for Mac and Windows computers, but I suffered also those versions. Still a little bit problematic, and that is why today the interview of today is going to be very useful for you. Today we are going to interview Gonzalo Casas, who is a software engineer at Gramazio Kohler research group. It's a research group inside the ETH Zurich. And Gonzalo is the main developer of a library that is called the ROSlibPy. So he is going to explain us what is this ROSlibPy and how can we use it in those machines where you don't want to install ROS on them. So welcome to the podcast, Gonzalo.
Hello, thank you for having me here.
My pleasure here. And so you are from your accent. So your surname is Gonzalo. That is very common here in Spain. But I think that from your accent, you are not from Spain. Where are you from?
I'm from Argentina originally.
Okay, great. But you are at Zurich now.
But I've been living in Zurich for a good number of years.
For doing research or development or working?
I've been working for ETH only for the last couple of years. So before I was working in software engineering, different fields, mobile development, BPM engineering, whatever.
Okay, so it has been there at the ETH Zurich that you have developed this ROSlibPy library?
Mm-hmm. Yeah, exactly.
Okay, and can you tell us what is the ROSlibPy?
ROSlibPy is a library, a Python library to access ROS from outside a ROS environment. This is the key problem that we had here. We needed to use ROS from Windows machines, and as you mentioned, it's really painful to install ROS on a Windows machine. So we tend to use it as a Dockerized application or as a virtual machine.
Okay.
Or basically externally from the Windows machine, and we need to interface to it from different environments.
Okay. So you wanted to avoid this Dockerization or virtualization machine of ROS inside a Windows machine. You wanted to avoid that, and because of that, you have created that library.
No, actually, we wanted to interface to that. So we do use ROS. We have a very interdisciplinary team here.
Okay.
So this is mainly an architecture school in this department. So I work for the Institute of Technology and Architecture. This Gramazio Kohler group belongs to this group. So it's primarily architects doing parametric design, but we have collaborations with roboticists and mechanical engineering. So in this ecosystem of different fields, everyone works with a different setup. Some, like roboticists, work with Linux machines using ROS as it's used generally.
Exactly.
But architects, they use CAD software that runs on Windows only. So they need to interface with ROS without being able to run the full thing, or not having it in the same computer at least.
Okay.
So our solution was to create a Python library, and the particular thing here was that we run this mostly inside Grasshopper and Rhino. Rhinoceros is this Rhinoceros 3D software that has a scripting environment called Grasshopper that runs Iron Python, which is this .NET implementation of Python. So it's not really C Python, and then our library had to work in both environments to be able to connect from there to ROS and do the whole mapping.
Okay.
So for that, basically, we rely on this ROS bridge and the ROS Web Tools project that breaches all the topics and services and so on from ROS and exposes them as a WebSocket server.
Okay. And so you have mentioned a lot of different technologies, and now I'm quite a little bit lost about what would be the typical setup that you are using. So how can you create a picture for all of us? Bear in mind that we are just listening. So can you create a picture of what is executed where and what connects to what? Can you tell us a little bit how would be the pipeline of connections from starting from the CAD software that you are using and finishing in the ROS robot or ROS simulation?
Yeah. So the setting or the context to understand this is that we're doing digital fabrication. So the development, like what an architect designs in this setting, is usually described in code. So they, instead of drawing in 3D, they tend to describe models as Python code. Okay. So that's how they start building the building or whatever is the element that is going to be built. And one of the driving forces in this field is this whole idea of integrating the fabrication into the design, so that whenever you are designing, in old school architecture, an architect would draw floor plans and then throw them over the wall for a constructor to build. What this new generation of architecture is doing is merging these phases into something that takes into account fabrication constraints during the design phases, so that you can say you're building a wall, to put in a simple example, right? You're designing a curved wall. You build it in your CAD environment, but you know that you're going to actually build it with a robot. So you need to take into account the robot reach, and you need to do path planning while you're designing, because you don't know if it's going to be even reachable for the robot that you have. So that's why we interface with ROS. So we connect to the scripting environment in the CAD software. And we allow the architect, which is designer basically, to do things like path planning while he or she is designing, so that can design knowing that it will be actually buildable.
So and did you use a simulation for that? So the architect that is designing those CAD files, it's testing that with a simulation, or why? So the point that I don't get is, so for what are you using the robot at that stage, while constructing this CAD file for the building?
Maybe it helps to visualize a typical setting in which this is built. Imagine you have we tend to work with industrial robots, like
Okay.
six
Arms.
degrees of freedom arms.
Okay.
Oftentimes they are mounted on external axes. So we have, for example, one setup here with 6 degrees of freedom arm on a linear axis, and then another 4 robots mounted on the ceiling that have 3 additional degrees of freedom. Those are collaborative, so they work. They tend to be used for the same project to do to build whatever it's being built at the same time collaboratively. So the designer needs to plan the fabrication such that there won't be collisions between the robots
I see.
with the elements that are being built.
Yeah, so they don't close the space. What you are building in one side, but then don't close the space for the other arm to cross to the other side, or to bring some material from one side to the other.
For instance, and then there are more elaborate constraints, like very often sometimes it's proposed that the building element is built without scaffolding, right?
Okay.
Because you can do scaffolding or support with the robots. So you use one robot to support the structure while the other one is placing the next element, and then they switch, for instance, and then you start this play or interplay between the robots to avoid building expensive scaffolding.
Okay,
and then being able to construct something that is non-standard.
Wow, that sounds amazing, super interesting. Do you have any video of this that I can put a link afterwards on the notes of the program for the listeners? So
yeah, sure.
Do you have video? Okay, but because I would like to see, I didn't get that while I was doing the research for your interview. So I just was maybe only concentrated on the ROSlib part of it. Okay, so let me read the note here.
ROSlibPy is kind of only a small piece in the puzzle.
Okay.
It was a starting point, and on top of ROSlibPy, we built another library called Compass Fab, which is for aimed directly at digital fabrication and robotic fabrication. That uses this library to communicate with ROS. So a typical setup on a designer's machine would have a Dockerized ROS instance with Moveit for path planning, for motion planning.
Okay.
Probably also drivers to control the robots. And then they can launch different Docker setups that during the planning phase, it's just the simulation, path planning, and so on. But then the designer is usually the person in charge of the fabrication. So they'll go to the fabrication floor and actually build a thing, for instance.
Wow, sounds amazing. That setup, I think that is one of the most complex that I have heard of, of using ROS, because usually we think about ROS usages, whatever. It's inside a robot, so you create a robot and then you put there, or you have a remote computer that is controlling another robot, and then the ROS is in the computer, things like that. But that one, wow, that's amazing. Yeah. So now I get the picture of why you needed this library. Okay, so you need to communicate Windows program in Python that is basically inside the CAD software.
Yeah.
But it could be from any Python program in a Windows machine, in a Mac machine, or also, of course, in a Linux machine, of course.
Yeah.
And then this machine and this code doesn't have installed ROS inside, and then it needs to communicate with a ROS system that it's a real ROS system, and that's the interface of this library that is there.
Yeah.
So that library can be used by anybody for any other project. It's universal in that sense. It's not attached to your particular project.
Yeah, exactly.
Okay. Very, very good. So now I got the picture, and then in that sense, you need to have the ROS bridge started on the ROS side.
Yes. Sure.
Because the communication is performed through WebSockets.
Exactly. So it's only we use only the WebSockets.
Okay. And which functionality are you providing with this library? You know, because in ROS we have many things like topics, services, actions. Which of those are you providing already? It's fully supporting ROS?
It covers basically all the basic stuff, like all the fundamental concepts. So topics, services, actions, the TF library stuff. All those things are the library is kind of feature parity with the official ROSlib clients. You know, the robot web tools people created ROSlibJS for JavaScript.
Okay.
And we basically took that and ported the same approach into Python, making it a little bit more Pythonic perhaps, but the same functionality basically.
Okay. And then you mentioned before, well, before that question, so which version of Python do we have to have installed in our computer in order to use ROSlibPy?
Any. We do testing, so we make sure that it works in 2.7, 3.6, 3.7, and
okay, 2 and 3. Great.
And also the IronPython one, which is it's fixed to be 2.7 because there's nothing else.
Okay.
But it should work in all the 3x versions as well. Although we don't actively test 3.3, 3.4, but it should work.
Okay, now that you mentioned that about this IronPython thing, what is that? That's the first time I heard about it. I'm sorry.
IronPython is an implementation of Python on top of .NET.
Okay, so for Windows systems.
Any
system.
In theory, it's also for the Mono runtime
in
that
Linux.
runs in Mac and Linux also. And in principle, I think it's also should work in this new cross-platform .NET that Microsoft is releasing. But IronPython development was a bit stuck in time. The last version was 2.7x. It's only recently that they kind of picked up the project to port 3x Python into IronPython.
Okay, and why would be the reason to use IronPython instead of the typical Python installation, the official?
It's not our choice actually.
Okay.
I mean, if we could avoid it, we would. But Grasshopper and Rhinoceros, this CAD environment, is a .NET application, and the whole scripting is built on top of .NET.
Okay.
And they are providing the scripting in Python using IronPython as an interpreter.
Okay,
so,
got it.
And we were kind of forced to do that. ROSlibPy is transparent about the Python implementation. So you run it the same. Internally, it switches WebSockets implementations completely. So if you're on CPython, it uses Autobahn and Twisted. And if you are in .NET, in IronPython, it uses the base library, the standard library of .NET to do WebSockets. Okay,
now makes sense. And do you know, well, I know that you know, so it's another product that is called ROSdoc. ROSdoc that was created by my friend Sam Pfeiffer. Sam, hello, if you are listening to this, hello, how are you doing in Australia? We interviewed him here at the podcast also on some previous episodes. And then he released this ROSdoc library also that is quite similar to yours. Have you checked it at least, and can you tell us what is the difference so people can decide which one to use, either ROSdoc or ROSlibPy?
I did talk to Sam actually a while ago.
Nice.
ROSdoc is similar, or there is a part inside ROSdoc that is very similar to what we do. He has a a Python client for ROS, for the ROS bridge, inside ROSduct that basically does something very similar to what we do. But the main purpose of ROSduct is different. They do this proxying between ROSs or ROS cores so that you can channel a topic from one core into a different one. But that part, that little ROS client that they have inside the library, is functionally identical to what we have.
Okay.
The only difference, which means that we cannot use it, is that it doesn't work on Iron Python. So yeah, we needed something else. But it's not that the reason why we created a different library. It was just a coincidence. We released this one a few days before or after.
It wasn't
announced this one. I think there is a thread in the forum about it.
Exactly.
So it was just coincidence that we developed at the same time.
Yeah, well, that's what they say, that the inventions, they do occur at the same time in different points of the world, almost with a few difference of days of difference. So I think that was the case here. Okay, very good. And then another question that I think that the listeners will be very interested is, for which version of ROS is this library working? Is ROS 1, ROS 2, both?
It's both in principle, because we are a relatively small team in terms of software engineering power. So we cannot really support and actively migrate from releases of ROS all the time.
Okay.
Like, it would be too much of an effort to migrate constantly from Kinetic to Melodic to whatever, and then to ROS 2. That's why we settled for the ROS bridge as a transmission protocol, because it's stable across releases.
Yes.
So it works in ROS 1 and in 2. It works across different releases of ROS 1. So we can reduce the effort that we need to.
Yes. Okay. So basically, what you So basically, what you mean is that the support from your library. So the versions of ROS that your library supports depends on the ROS bridge that is installed on the other side.
Yeah, exactly.
That will be so. If you install a ROS bridge that supports Kinetic, then yours is supporting Kinetic, because the protocol of communication between your library and ROS bridge, it's the same. It's very unlikely that it changes. Okay, I see.
Yeah.
Okay.
And there was one, I think, since the beginning of ROS bridge, there was only one change in the protocol from the protocol version 1 to the version 2. But that was long ago, I think, in Fuerte or Groovy or one of the earlier releases of ROS. But ever since, it's been stable.
Okay, that's why you are specifying. I read your specification requirements for your library, and then you're specifying that you require ROS bridge version 2.
Yeah,
that
which is basically the only one available.
Yeah,
so
okay.
The other one is deprecated. It's not really possible to use.
Okay. And finally, can you tell us any application or any other people that are using your library apart from your team and for doing anything interesting that people can check as an example afterwards, can go and see how they have used your library and they can relate or apply to their own system? Are you aware?
I'm not super aware of the exact implementations or applications that are using it, but one of the interesting applications I saw in the GitHub issues of the library at some point was people using it within a ROS system also, or from a Linux computer, and one of them was measuring performance using ROSlibPy and ROSlibPy at the same time to check delays and things like that. I found that one interesting.
Okay, so like profiling.
Kind of profiling.
Okay. And you mentioned that this is on the list of issues of ROSlibPy.
Mm-hmm.
Okay. Okay. I will have a look for looking for that mention that you said, and put it also on the links after beneath the podcast.
Okay. It was more like a conversation between two people, one asking for something better.
Okay. Then in that case, I will just link to the issues of the ROSlibPy library, and then in case that you listeners that you are listening this and you are interested to see how that works, then you can just go there and check the conversation and see if that applies to your particular case. Okay. So now it's more clear for me. I had so many questions here, so in order to understand, I think it's a very good idea, because yes, you are offering this actually to opening to any system, not only to Windows machines, that's your particular case, but in any other system that supports Python, then they can access to the information there. That's super cool. We had another episode on previous podcasts of that we interviewed. I don't remember now his name. So he was creating for Swift. Let me check here, because it was. So he was using this for Swift. Yes. Okay. So it's Thomas Gustafsson, and then he was creating also a client library for accessing to ROS from a Swift program. So that would allow also to iOS devices to access, and then you can represent on the mobile phone. But the same functionality is what you are providing this for any other type of machine that supports Python. Okay. So thank you very much, Gonzalo. It's been very clarifying, very interesting presentation, and thank you very much for being at the podcast.
Thank you for having me here. And cool
so
stuff.
you're going to keep to maintaining this library, isn't it?
Yep, absolutely.
Okay, so listeners, any questions that you have, any issue, report to Gonzalo, and he is going to answer you and help you and debug or whatever that needs to be done. Yes. Thank you, Gonzalo.
Thank you. Bye-bye.
And for all the listeners, remember that if you want to learn ROS fast, there is no better place than the Robot Ignite Academy. At the Robot Ignite Academy, you will learn ROS online, practicing in an integrated web environment that contains the lessons, the simulations, and the code development tools. Everything together integrated into a web browser. It doesn't require an installation on your computer, so you can use any type of computer, and it's really the fastest method to learn ROS and all the related subjects to ROS, like ROS for autonomous cars, ROS for industrial robots, machine learning applied to robotics, etc. Have a look at this address. Very simple. robotignite.academy. Very simple. And that is all for today. Thank you very much for listening. See you all the next week with a new lesson from the expert. And until then, keep pushing your ROS learning.
The ROS Developers Podcast. The ROS Developers. The ROS Developers Podcast. The ROS Developers. podcast, the